In Learning Objective C, I'm going to show you how to do what's called the outlier test and determine if a data set has any outliers. First of all, let's define what an outlier is. It's a piece of data that just is out of the pattern of the data. It might be a number that's way too big or way too small. And there's actually a numerical test you can do to see if a number, even if it looks like it's out of the pattern, if it really is. Outliers are important to test for because of this. They can have a significant impact on the mean. They can really skew your mean and make it too high or too low. They may be important though because they may represent a special case. So just because you have an outlier doesn't mean you should remove it. You just have to be cautious that it's in your data. And here's how the test works. First thing you have to do is you're going to find your IQR. Remember, IQR is Q3 minus Q1. Once you have that, there's two different sides of the test. There's the upper end of the test, which is number 2, and there's the lower end of the test. You're going to take 1.5 times the IQR and take that number. What you're going to do is take that value, 1.5 times the IQR, and you add it to Q3. Any number higher than this is considered an outlier. On the back half of it, you're going to again take that 1.5 times the IQR. You're going to take that value and you subtract it from Q1. Anything smaller than this number is considered an outlier. So we have a test on the high end and we have a test on the low end. You must show both sides of the test are being done. So here's an example. We have a 5-number summary for the Major League Baseball players. It's their payroll data in millions of dollars. So this is the total payroll for the various teams. And the minimum amount a team pays is $24 million. The maximum amount is $190 million. The team in the 50th percent is $84.5 million and so forth. So here's what we do for the test. They're going to say, first of all, find the IQR, which is Q3 minus Q1. So quartile 3 is 100, quartile 2 is 62. Subtract, we're going to get 38. Now the test says take 1.5 times the IQR. So I'm going to take 1.5 times the number 38, which is going to give us 57. Now, the top end of the test I'm going to do first. It says take Q3 and add to it 1.5 times that IQR. Okay. Q3 was 100. I'm going to add to it the 57. Any team that makes more than 157 million, you can make 157 million, that's fine, but if you make more, you're an outlier. So if you look at the data set, we've got an outlier right here at 190 million on the high end. Now, test the low end. It says take Q1 and subtract from it 1.5 times the IQR. Q1 in this case was 62. If we take 62 minus the 57, that's going to give us 5. So any team that makes below $5 million is an outlier. There is nobody making below that, so there is not one. So the only outlier in this data set is the team that makes $190 million. On this last slide, I want us to compare histograms and box plots to see how they are connected. Now, the one thing that these graphs do give us is information about the shape and the distribution of values of the data. So if you take a look at this, what you're going to notice is I want you to match the appropriate histogram with which box plot. So this histogram letter C here, if you look at it, it has the shape which we call symmetric, and it's equally balanced. So if we look at it, the median of the data probably sits there right in the middle. And then you're going to see on the lower half is the bottom 50% of the data, on the upper half, the top half, and it's equally balanced. Well, remember, if we look at the box plot 1, the median is right here. And you notice how nicely balanced this is. the lower 50% of the data sits from quartile 2 all the way down. That's 50% of the data. Well, from quartile 2 all the way to the maximum is another 50% of the data, and it's nicely and equally balanced. So therefore, histogram C and box plot 1 go hand in hand. Well, take a look at histogram A. On histogram A, most of the data is right here on the far left. There's this tiny little piece way over to the right. But the middle of this data distribution is probably way over here. So which box plot has quartile 2 or the median way to the left? Well, it's this guy right here. This one is way over to the right. And this one out here, this little bar is an outlier. And what they've done is they made this box plot into a modified box plot, which means they did the outlier test on it and they figured out who was the outlier. And instead of making it a complete whisker all the way to the end, they identified the outliers with a dot. So that's what a modified box plot is. So histogram A and box plot B, or 2, go together. And the last matchup is histogram B. If you take a look at histogram B in terms of shape, we would call this skewed left because the tail is to the left. And the data is pulled way over to the left. If you look at this one too, the middle of the data is probably right in there, where that's where we see the median on this box plot. And then you also see this little minimum value pulled way over to the left, just like the histogram is too.